Hi there, welcome to another college math video. In this video, we're going to get the basic truth tables for the last of the 5 connectives that we look at, the conditional and the biconditional. So our objectives for this video: construct truth tables for conditionals and biconditionals. This will be the basic and then combinations. And then we'll also determine whether a statement is a tautology, self-contradiction, or neither. These are just special scenarios. And then solve application problems. So a few notes before we get to those truth tables, which is really going to be the heart of what we do, are on tautology and self-contradiction. So these will be, as the objective said, tautology, self-contradiction, or neither. This is just something we'll identify after we fill in the whole truth table. Then we'll ultimately be able to say, basically, is there something special about this? Is it a tautology? Is it a self-contradiction? Or is it neither? So a tautology is a compound statement that is always true. So essentially, it's just something we'll look at the end to see, is there something special about this statement? Is it a tautology? And then self-contradiction, tautology is one end of the spectrum, it's always true. Self-contradiction is the complete opposite end of the spectrum. It's a compound statement that is always false. So after we fill in a truth table, we'll now be able to answer, is this statement a tautology? All true. Self-contradiction? All false. Or neither. Is it something in the middle? Are there a combination of trues and falses? All right. So let's get these basic truth tables, the conditional and biconditional. This is again going to be really the heart of this section. Remember, the conditional is your if-then statement. If, blah, 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 then something else. And each of those ideas will be something that can be deemed true or false. So let's come up with an example. We'll use, again, just this first time, words to come up with what the overall value of this statement should be. And then we'll use that truth table for everything else that has a conditional. So the statement we'll use: if you are French, then you eat snails. Remember, you have to take all of your biases about anything out here. It could be that you're French and you do eat snails. Could be you're French and you don't eat snails. You might not be French and you might eat snails. You may or may not. So let's just go back to the basic kind of detective work idea here. This is definitely conditional because we see if-then. The if-then, remember that symbol is the arrow from pointing to the right. And then the two ideas that can be deemed true or false: you are French, this could be true or false, and you eat snails, could be true or false. So let's set up that same basic framework for the truth table. We have ideas P and Q, which means a total of 4 combinations of true and false. And you don't have to put them in this order, but I strongly encourage you to put them in this order. This is the basic framework. We haven't actually evaluated the conditional yet. True, true, false, false, true, false, true, false. And now we can do the conditional. If P, then Q. If you're French, then you eat snails. This is the claim that's made. And so we have to run through each of these 4 scenarios. We'll think through them individually this time. After this, we've got the summary, and we'll just plow through. All right, so the first scenario, behind the scenes, it is true that you are French, and it's true that you eat snails. So if the statement is made, if you are French, then you eat snails, the overall value of that statement is true, because you're French, and you do eat snails. Second scenario, it's true that you're French, and false that you eat snails. So the statement is made, if you're French, then you eat snails. Well, you are French and you don't eat snails, so that statement would be false. All right. This third and fourth scenario are probably the most difficult for students to comprehend, so I'm going to talk through it a few different times. Bear with me. First, third scenario says, it's false that you're French and true that you eat snails. So the statement is made, if you are French, then you eat snails. What do you think the overall value of that statement is? You're not French, but you do eat snails. The statement, if you are French, then you eat snails. This is really tricky because we are not meeting this first criteria, the if something, then something else. So it's really difficult to decide should the overall value of this sentence be true or false if we don't meet this first criteria. We're not French, so how can you say anything about how you feel about eating snails? When it comes to the conditional, the approach is sort of like innocent until proven guilty. It's more important to be able to prove that something is false. So if you can't prove that something is false, you can't prove that a wrong was done, then you're innocent, then it's true. Which is really hard to grasp, but at a certain point, you just have to go with it. This is for the study of logic. So in this scenario, you're not French and you do eat snails. Since you don't meet that first criteria, we can't really say anything about how you feel about snails. We can't prove that it's a lie, so by default, it's true. That one's the most complicated to understand, even of 3 and 4. Let's look at 4 then. The last scenario, if you are French, false, then you eat snails, false. Each individual piece is false, so if you are French, then you eat snails. Again, you're not French, so how can we say if you eat snails or not? We can't make any judgment about that. We can't prove that it's an outright lie, innocent until proven guilty, so you must be innocent, it must be true. I agree, it's somewhat uncomfortable to put down true, but I hope you'll agree that it's equally difficult to want to say, well, it should be false. It feels to me more like something that should fall in the middle. We can't really say if it's true or false because you're not French. In both of these scenarios, you're not French. So I can't really say if you do or don't eat snails. As a default, anytime it starts with false, it's overall, the statement is deemed true because we can't in a hard, definitive way prove that it's false. I know it's a difficult one. Good news, biconditional is not nearly as complicated. So this is the basic table for a conditional. Just as we did for conjunction disjunction, let's come up with a basic summary of this. So what is one way you could summarize this? What's special about this table? Besides that it's complicated. I would say the one that sticks out to me and the way I'll summarize it is that it's only false when true leads to false. So if true leads to false, then it's false. A conditional even in the summary. Everything else is true for a conditional. There's one other really important note to write down about the conditional table. This is something we'll have to consider every time we do an evaluation that involves a conditional. You might notice for our other tables, conjunction and disjunction in particular, that it didn't really matter what the order was. Making the statement, I have a dog and I have a cat versus I have a cat and I have a dog, it has the same meaning to switch the two around. But it's very different to swap these two ideas. If you eat snails, then you are French. That's a totally different sentence. So when it comes to the truth table, for the conditional in particular, the order is important. More good news. Conditional is the only one that happens for. For everything else, the order should be able to be swapped around. So 2 things, order is important, and true to false means false. Everything else true. Okay, let's get the table for the biconditional. Remember, this is a statement connected with if and only if, or potentially IFF if you've seen this before. The expectation is pretty much that you're going to stick with the if and only if. All right, so let's get an example here. The example that we can base our initial truth table off of here. You get the job if and only if you have 10 years experience. This is definitely a claim or a similar type of claim that an employer could make. You get the job if you've got the experience. And the biconditional is supposed to work that the two ideas can be swapped. So this sentence doesn't necessarily sound great if you swap it. You have 10 years of experience if and only if you get the job. But the idea is supposed to be that one thing leads to the other, which they both kind of lead back to each other. All right, so the ideas that can be deemed true or false here: you get the job. That could happen or it couldn't happen. And you have 10 years experience. Maybe that happens, maybe not. Let's see what the biconditional looks like then in the truth table. We have two ideas, P, Q, so we've got the same four scenarios. True, true, false, false. True, false, true, false. And we're pulling them together. Again, this is our basic framework, but we're pulling them together with the arrow that goes in both directions. It should probably be more condensed, but I always write it wider. P, if and only if, Q. And we're going to think through all four scenarios now to come up with this basic table so that we don't have to think about it from here on out. All right, so the first scenario says it's true that you get the job and true that you have 10 years experience. So if the employer makes the claim, you get the job if and only if you have 10 years experience. Are they telling the truth or lying? It's true that you got the job and true that you had the 10 years experience. Their claim was true because experience led to the job and the job meant you had the experience. The second scenario, it's true that you get the job and false that you have 10 years experience. Sometimes employers make that claim that you need this experience to get the job, but then hire outside of that. So true that you get the job, false that you have the experience. Was the employer lying or telling the truth when they said you get the job if and only if you have 10 years experience? Well, you got the job, but you didn't have the experience. So while you're happy you got the job, that statement is not true. That statement is a lie because 10 years experience wasn't something you needed to get the job. Third scenario, it's false that you get the job and true you have the 10 years experience. Definitely something that could happen, but the way this sentence is set up means that experience leads to the job and the job means you had the experience. So you didn't get the job, but you had the experience, so that statement is a lie. False. And then the final scenario, it's false that you get the job and false that you have the 10 years experience. So when the employer makes the claim, you get the job if and only if you have 10 years experience, was the claim true or false? Often I hear people say false because false, false has to lead to false. But no, you didn't get the job, you didn't have the experience. So when they made that claim, they were telling the truth. Having the experience would lead to the job. Getting the job meant you had the experience. And you didn't get the job, you didn't have the experience. So that statement was still a true statement. So this is your basic biconditional table. Let's come up with a summary, and then we can use that summary along with the other summaries to fill in all combinations of conjunction, disjunction, negations, conditionals, and biconditionals. So looking at this table, how do you think you could summarize it? This might feel a little more difficult because there's not one special thing that stands out. We have 2 and 2. In every other case, there was 3 of one thing, 1 of another. So how I would summarize it if it was me, having the same value led to true. If they're both true, true. If they're both false, false. If they're opposites, false. That's another way you could summarize it. Opposites are false. Okay. All right, so these are the basics: conditional, biconditional. Now we'll start to do combinations of them. Okay, so some examples with me. Create a truth table, and then remember we're also going to now identify when the question is asked, but for this section, pretty much all the time, if the statement is a tautology, self-contradiction, or neither. So is there anything special about it? Or no? So first one, we have the negation of negation A leading to B. We definitely have a conditional here, but I also see a few negations. So let's build our truth table. We still have 2 ideas, so our basic framework will involve the 1, 2, 3, 4 scenarios. True, true, false, false, true, false, true, false. I'll definitely be filling in this framework a little bit quicker now that we've discussed it a few times, more than a few times. But recognize again, there's a pattern. This isn't some like crazy weird scenario to fill in. There's a pattern. 2 true, 2 false. True, false, true, false. Starts the same every time. All right, so big picture here is the negation of this parentheses, but we don't yet have the parentheses, so we kind of zoom in on that. Inside the parentheses, negation A leads to B. We don't yet have negation A. So let's first come up with a column for negation A. Negation A is simply the opposite of A. So true, true, false, false becomes false, false, true, true. Then we can do the whole parentheses, negation A leading to B. Negation A leading to B. So this is the conditional. Let's just get this ready. So the symbol that we're focused on is definitely the conditional symbol, but which 2 columns do we focus on? The 2 listed, negation A and B. So what's our summary for the conditional? The only time we had false is when true led to false. True to false is false. But what's the other important note for conditional? Order is important. So thus far, we've been able to just kind of look left to right, but with conditional, we're going to have to make the decision which way to look. Since we're starting with negation A and going to B, we need to do the same when we evaluate. So in fact, here, we're going to be looking from right to left. It won't always be that way. Sometimes it will be left to right. You just have to always make that decision. Negation A is first, so that's what we start with. And the only time we get false is when true leads to false. So, do we have that in any of these rows? We do, in fact. It's for the last one. True leads to false is false. Everything else is true. So that's our conditional column. Now, ultimately, we can do the whole thing. We've got this parentheses. All we have left to do is the negation on it. Negation of, negation A leading to B. And so we're simply focused on that previous column and we're taking the negation of it. So the opposite. True, 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 false becomes false, 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 true. All right, let's do, before we move on, we should then also answer, is this a tautology? Is everything true? No. Self-contradiction, is everything false? No, so it's neither. Nothing special about this. Okay, next one. We have A, if and only if, negation B. So, 2 ideas. We'll set up the same initial framework. 1, 2, 3, 4 scenarios. True, true, false, false. True, false, true, false. If I'm filling it in quick, just pause the video, fill it in on your own. You've got to get used to that pattern of filling in this basic framework because filling in truth tables is so much of what this chapter is. Okay, so big picture, we want this whole statement, the whole big biconditional statement, but we don't yet have a negation B. If we attempted to do this right away, we would look for A and negation B. We don't have negation B, so we make that first. Negation B will simply be the opposite of B. So true, false is false, true, false, true. And then we have everything we need because we just have the biconditional connecting A and negation B, and we have both of those things, A and negation B. If and only if it was me on paper, I would be covering up that B column so I could just see the 2 I care about. And the summary for your biconditional is if they're the same, then it's true. So let's look for those. Which rows do we have the same? Looks like the second row, we've got both true so that's true. And the third row, we have both false, so that's true. Everything else has a mixture, false. So our final column, false, true, true, false, based on this framework. All right, then the final consideration, basically, is there anything special about this? Is it a tautology, self-contradiction, or neither? Not all true, not all false, so neither. It's pretty uncommon to get tautology or self-contradiction. Those are the two far ends of the spectrum. Typically, your table will involve some combination of true-false, but there are statements that can be made that are always true or that are clearly always false. I think we'll see an example as we move on. All right, so let's do a little practice. Go ahead, pause the video, go through these on your own. Don't forget to answer the question, tautology, self-contradiction, or neither, and then we'll go through them together. All right, so let's see if we're on the same page. Again, I can't stress the importance of the practice on your own for these types of problems because the truth tables, it really just takes some getting used to. Once you have this strategy down, I promise you this stuff goes really quick. All right, so the first one we have ideas R, S, and P. And if you didn't, it's just going to be more difficult to follow along, but they should be in alphabetical order. P, Q, R, S. There we go. P, R, S is going to be in alphabetical order. And there's three ideas that are true or false, so there'll be 8 total combinations of true and false. 3, 4, 5, 6, 7, 8. All right, so we have the same pattern, 4 true, 4 false. 2 true, 2 false. 2 true, 2 false. And then alternating. Okay, so big picture, the important thing is this conditional. If blah, 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 then this thing. And we can tell that that's the important because there's a parentheses pulling that stuff together. Okay, so focus on that parentheses. We need negation R and negation S to be able to pull them together. So we'll find each of those individually first. I'm choosing to do negation R first. If you did negation S first and then negation R, would totally be fine. There's some parts that have to follow a specific order, but some things can be done in different orders and it doesn't matter. All right, so negation R will come simply from the R columns, the opposites. False, false, true, true, false, false, true, true. Negation S becomes false, true, false, true, false, true, false, true. Now that we have those two columns, we can pull them together with the word or inside the parentheses. Let's do this so we know. Negation R or negation S. And this one is going to come from the two columns we just created. Negation R, negation S. They're being pulled together with the word or. What's our or summary? You may have to look back for this. If there's at least one true, then it's true. If I say I like this or I like that, and I like at least one of them, maybe both, then my statement's true. So looking at just those two, we're looking for where there's at least one true. The second line has it, the third, the fourth, the 6th, 7th, and 8th. So the other two are false. And now that we have the parentheses, we're able to do the whole thing because we have P and we have this parentheses. So the final, expand it a little bit, we'll be pulling together this parentheses and P with the conditional. So the two columns that we're focused on are the one we just built and P. So our summary for conditional is that if it's true to false, then it's false. Everything else true. And it's important to note, order is important. So the parentheses is what's first, and P is second. So we're looking again from right to left. Just depends how it's set up. So the only time we get false is when true leads to false. So let's look for that. No, true to true, true to true, true to true. No, oh, the last three are true to false. So these are false. Everything else is true. If your letters were in a different order, you're going to have to compare each scenario, figuring out which rows match up. It's very complicated, but it can be done. So ultimately we get 1, 2, 3, 4, 5 trues and then 3 falses. If you see that in the end and your letters were in a different order, you've probably done it right, but without really checking, it's difficult to say. Okay, then the big consideration, is this a tautology, self-contradiction, or neither? Tautology would mean they're all true. Self-contradiction, they're all false. This one's neither. Nothing special about it. Neither. Okay, then the second practice problem, we have the biconditional pulling together P and negation P. I imagine some of you set up the table different than I'm about to, because this is what you're used to doing, but there's only one idea here. There's only idea P. Sure, there's also negation P, but that's still just an alternate version of P. So there's only 2 scenarios. P could be true or false. If you set it up to be true, false, or you set it up to be longer and include another letter, you would just be doing this consideration more than once. But you don't have to. So ultimately we want P, if and only if negation P. We have a column for P. We don't yet have a column for negation P. So we'll make that. It is simply the opposite. True becomes false, false becomes true. And then we can pull these together with the biconditional P, if and only if, negation P. And we're going to focus on these 2 columns. Remember our summary for biconditional. If they're the same, then it's true. Well, true, false, false, true. We don't have any that are the same. So these are both false. Then the special consideration, is this a tautology? All true. Nope. Self-contradiction, all false. This one, in fact, is a self-contradiction. I wanted us to see at least one that fit one of these criteria. This is a really basic self-contradiction. Let's say idea P was, I like dogs. I do like dogs. That's why I use this example a lot. But maybe that's true, maybe that's false for anyone. So this statement essentially translates to, I like dogs if and only if I don't like dogs. Doesn't work, that's a self-contradiction. That means liking dogs leads to not liking dogs, and not liking dogs leads to liking dogs, and that doesn't make sense. It's always false, self-contradiction. It's a really basic example of a self-contradiction. There are much more complicated ideas that could be false in every case presented and could be true in every case presented. But it's pretty complicated to get those. For the most part, there's going to be some mixture of true and false, but these are those 2 far ends of the spectrum. All right, so just a tiny bit more. Oh no, I added 2 more. Okay, more practice problems. Yes, these are both good. So go ahead, pause the video. This first table, now that you've seen, and really I hope that you'll go through in alphabetical order so we can compare the same way. And then the 4th scenario is another special case where we know the truth value of each of those ideas. And then we'll kind of bring it back together with some words. So go ahead, pause the video. We'll go through together in a moment. Okay, so let's see if we're on the same page. Now that we've done this a little bit more, I promise you, as this chapter continues, it's just more and more and more truth tables. This is where we get down the basic ideas of how to do them. All right, so we have ideas U, V, and S. So in alphabetical order, S, U, and V. All right. So let's set up the 8 lines and then we'll start filling this in. So we have 1, 2, 3, 4 true, 1, 2, 3, 4 false, 2 true, 2 false, 2 true, 2 false, and then alternating. Okay, so the big picture of this statement is definitely the biconditional, but it's being pulled together with a negation U, which we don't yet have. So I'll start there. Negation U comes from U. Opposite will be false, false, true, true, false, false, true, true. And this parentheses, which we also don't yet have. So let's focus on getting that parentheses. Within the parentheses, we have V and negation S. We don't yet have negation S, so we'll do that next. If you started with the parentheses first, so you did negation S, then you did V and negation S, that's fine. Then negation U. The order doesn't necessarily matter there. Our final column will be the same. Negation S, opposite of this one, so 1, 2, 3, 4, false. 1, 2, 3, 4, true. Then we can pull together V and negation S. Whoops, I should say for negation S, we focused on S. For V and negation S, we're going to focus on V and negation S. They're being pulled together with the word and. If it was me on paper, I'm going to cover up everything I don't care about and just focus on V, negation S. Our summary for and. It's important, if you don't remember them offhand now, to start looking back and write down the summary of the 4 summaries to reference quickly, because you can't just go off of me saying it every time. You have to know it, otherwise you're never going to go through these quickly. Our summary for and is that if they're both true, then it's true. That's the only scenario that it's true. So V and S, true, false, true, false, true, false, 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 true, false, 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 true, true, there's one, line 5, and line 7. Everything else false. Now finally, we can do the whole thing. We can pull them together with this biconditional. Negation U. And if and only if V and negation S. You might be wondering or thinking that you don't exactly know how to choose the order of things yet. And like I said, sometimes it doesn't really matter. Eventually they'll get to a point where it does. But what I would suggest is to kind of focus yourself as close in on something as you can and work your way out. So if there's parentheses, start there. Focus on that and then go from there. If there's individual negations, start there. That's always a really easy column to fill in, and then you can start going bigger from there to the big picture. So the symbol we care about here is the biconditional. Remember, our summary is that it's true if they're the same. So we're focused on negation U and V and negation S. The order doesn't matter here. We just are looking for the same to get true. So the first one, false, false is true, false, false is true, different, 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 the same, and different. You can fill them in line by line if you want. I think it's easier to look for one specific thing and then just fill in the rest with the opposite. So we get true, true, false, 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 true, true, false. And this is only if you set it up in the same alphabetical order as me. If it's in a different order, your final column is going to look different. Everything is just shuffled around. All right, then let's look at the second one. The second one, we only have one scenario to work through. P is true, Q is false, R is true. We're essentially doing the third line of the truth table, and that's it. All right, so we have quite a lot to find. I would suggest starting with those individual negations. For me, that's what jumps out. It looks like I need all 3 of them, so I'm going to go ahead and do those right away. True becomes false for negation P. For negation Q becomes true, and for negation R becomes false. Then I'll focus on either parentheses. It does not matter which one you do first. I'll just start with the one on the left. We have negation P. We have negation Q, so we can pull those 2 things together with OR. Negation P, negation Q. Remember our summary for OR. If there's at least one true, then it's true. False, true, so it's true. Then the other parentheses, negation P or negation R. We have a column for negation P, and negation R. Pull them together with or. If at least one true, then it's true. They're both false, so it's false. And then finally, we have each of these parentheses, so we can pull it together with that biconditional. And the symbol that we're focused on is that biconditional arrow. That's what we're pulling together. And it's pulling together the two columns that we just found, which were the two parentheses. And our summary for biconditional, if they're the same, then it's true. They're different, so it's false. Ooh, I forgot one other consideration for the previous table. It didn't say it there, but we can still answer. Is this a tautology, self-contradiction, or neither? Since we have a combination of true and false, this is neither. And for the one we just did, since we only have one line, you wouldn't have to worry about making that decision. Making that distinction is only if you're running through all scenarios. That's basically to point out, is there really something special about this statement? All right, so that's a lot of look at truth tables. Let's do a couple more problems. Just bring us back to why we're doing this, the translations back and forth, because ultimately as we move forward from this video, it's going to be a lot more, okay, now both things. You're going to do the word part, and then you're going to do the truth table and decide if there's anything special about it. So if we have idea P, you have a dog. Idea Q, your house is dirty. Idea R, your allergies are bothered. I want to do both things that we did back in that first video. Write this in words, so ultimately make this translation, and then write it in symbols. I think let's go ahead and do these as practice problems since we've done this before. So go ahead, pause the video, come back, and we'll see if this is something you're still able to do. All right, let's see if we're on the same page. So we've seen all these symbols before in translation and in truth table. We're only doing translation here, writing this in words. Negation Q and negation P, if and only if R. So the big idea of this sentence is definitely the biconditional, since it's pulling together a parentheses and something else. So let's translate that parentheses first. Negation Q. Q is your house is dirty, so negation Q is your house is not dirty. The down symbol is and. Negation P, P is you have a dog. Negation P, you don't have a dog. So there's that first piece, negation P and negation Q and negation P. Then we have biconditional, if and only if. Statement R, your allergies are bothered. So there's the sentence. There's definitely one thing missing from this sentence, and it's an important piece. Since there were parentheses, remember, parentheses indicates where a comma should go. Comma tells you where a parentheses should go. These two ideas were held together, so there should be a comma holding them together. This comma tells us to read all that stuff in the same breath. Your house is dirty and you don't have allergies. Oh my gosh. Your house is not dirty and you don't have a dog, comma, if and only if your allergies are bothered. All right, so there's a good word translation. Then let's go the other way, write in symbols. If you don't have a dog and your house is dirty, then your allergies are bothered. So it's the big idea of this sentence. The overarching theme of the sentence is definitely the if-then. So the arrow from right to left will be the big picture. Then we identify what's before and what's after the arrow. Before the arrow, if you don't have a dog and your house is dirty. More than one idea, and we see a comma, so that tells us there should be parentheses. You don't have a dog, which is negation P, and is the down symbol. Your house is dirty, Q. Then what comes after, your allergies are bothered, is statement R. This was just a quick reminder on how to do this because as we move forward, like I said, we'll be translating back and forth still and then also doing the truth tables. So this video in particular really focused on getting a good handle on the conditional and the biconditional truth tables. Because as we move forward, everything will get combined together. The translations and conditional, biconditional, conjunction, and disjunction. So I'll see you soon for another video where we will move forward with logic.